Here we have the SEL 2533 breaker simulator on the left with the Raspberry Pi RTU sitting on top. And on the right hand side of the screen is the VTScada operator display. On the VTScada display, there's a 3-breaker ring bus with 2 incoming 69 kV lines and a 69 to 13.2 kV transformer. This is a pretty typical configuration for a small distribution substation. Looking at the display and the breaker simulator front panel, we can see that all 4 breakers B1 through B4, are open. This is shown on the SCADA screen as a green color of the breaker. The incoming line voltages, which are the voltages displayed on the bus segments connected to the 801 and 802 lines in the upper left and right of the screen, are shown as 69.3 and 68.7 kV respectively. As all the breakers are open, the breaker currents, the megawatts, and the megavar values at all the metering points are 0. After closing breaker B1 from the SCADA, we get our little pop-up window here asking us to confirm, do we want to close breaker B1? We'll say yes, we do. The breaker turns red to show that it's closed, and we see the voltage on the 69 kV side of the transformer goes up to 69.3 to match the voltage of the 801 line that it's now connected to. Since there's still no path for load flow, all the breaker currents and the megawatt and megavar values remain at 0. Now breaker B4 is closed, allowing the 13.2 kV distribution load to be picked up from the 801 line. The megawatt and megavar values on the 801 line and number 1 bank transformer now show that 10 megawatts and 2 megavars are flowing into the distribution system. The currents through breakers B1 and B4 are also displayed. These currents are based on the system voltages, load flow, and the available paths. Next, breaker B3 is closed, allowing load flow from substation B to substation C via the 801 and 802 lines. Note the change in the real and reactive power flows, as well as the change in B1 breaker current. The 802 line voltage also rises to match the 801 line. Breaker B2 is closed next. With this breaker closed, a parallel path is created between the 2 sub-transmission lines. As this path is of the lower impedance, most of the 802 line load, about 80%, flows through B2, and the B1 and B3 currents are correspondingly reduced. Breaker B1 is now open, and we see that its current goes to 0, while the current through breaker B3 increases. This reflects the shift in distribution bank load flow from B1 to B3. B4 is open next, and we see its current go to 0, along with breaker B3's current and the megawatt and megavar flow through the transformer. The transformer high side voltage remains at 69.3 kV. After opening breaker B3, the high side voltage goes to 0, as there is no longer a connection between the transformer and the power system. Load flow through the 801 and 802 lines is carried by breaker B2, and the B2 current, megawatt, and megavar values remain unchanged. Finally, breaker B2 is open, and the system returns to its original state, with both lines energized up to their breakers and no load flow or breaker current.